Today I will be presenting my progress report on how artificial intelligence and Formula One aerodynamics and its applications to electric vehicles. The focus is on how AI is used in the racing world and how the innovations that are being created can be used on everyday electric vehicles. My project is an analysis on how AI is used to optimize aerodynamics in motorsport and commercial vehicles. Formula One can be considered the base ground for creating these technologies and helping advance engineering in the professional world as well as in the academic world. These designs are quickly showing up on commercial vehicles and improving them in every way. The goal of this project is to analyze how AI is used to optimize aerodynamics in the Formula One realm as well as in motorsport in general. More specifically, I am focusing on airflow management, drag reduction, and overall car efficiency. I also aim to connect these innovations to commercial vehicles, specifically electric vehicles, and show how they improve performance as well as the battery range. So my intended audience, or also known as my primary audience, includes automotive engineers, which are typically mechanical engineering students who get their master's in automotive engineering, as well as vehicle designers, such as designers on and a part of Formula One teams and any other commercial vehicle designer, and sustainability professionals who work with advanced vehicle technologies. So this could be anybody who's working on the car. Research from sources like engineering journals and MIT Technology Review shows that these groups rely heavily on AI-driven design because they're able to create a bunch of different designs and see which one works best for their car. A secondary audience includes engineering students as well as general readers interested in the automotive innovation. I know here on campus I'm a part of a club called Formula Kentucky, where we build a car that's based off of a Formula One car, and we practice the aerodynamics of it, and we run it through CFD and other things like that. So to provide some background on the topic of Formula One, it's considered to be a testing ground for cutting-edge engineering. If you look at the picture to the right, that is a picture of a Formula One car going through CFD. CFD just helps you see all the different kinds of airflow and how it's moving through and how the air will be moving on and around the car. Aerodynamics play a critical role in determining speed, stability, and efficiency because it's the first thing that the car hits is the air. The research problem I'm specifically exploring is how AI is transforming this process and such. Instead of relying on only wind tunnels, engineers can now simulate thousands of airflow scenarios by using AI, so it's able to help them quickly, cut their development time in half. This topic is important because these aerodynamic improvements directly impact commercial electric vehicles. In electric vehicles, reducing drag is essential because it improves battery efficiency as well as increases the driving range. Many innovations that start in Formula One are later adapted into consumer vehicles, which makes racing key to real-world technology progress. Basically, anything that's developed at the professional motorsport level will eventually trickle its way down to the commercial level. So the methods I'm using for this project are both secondary and primary research. So the secondary research I'm using are peer-reviewed journals, industry reports, and different publications based on automotive technology. In addition, I'm also doing some primary research, including a comparison analysis on the aerodynamic features of Formula One in electric vehicle cars, as well as a content analysis by using forums, engineering communities, as well as any automotive platform. So far I've completed a large portion of my research. I've identified over 8+ academic resources, as well as researched AI application in aerodynamics and how it's been being currently used in Formula One. I've also explored aerodynamic technology and how it's being transferred onto electric vehicles, as well as started connecting the findings to electric vehicle design. At this point, the research shows that AI is significantly improving aerodynamic precision by analyzing large data sets as well as conducting millions of simulations. It's also reducing the need for physical prototypes, which saves both time and money. And overall, AI is just allowing for faster innovation and better performing designs. So my analysis is suggesting that Formula One acts as a real-world laboratory. AI is providing a competitive advantage by enabling drivers to drive faster based on data-driven decisions, and these aerodynamic advancements are now being applied to commercial vehicles, specifically electric vehicles, improving their efficiency, range, and sustainability. Looking ahead, there are still things that I need to complete. I plan on adding some visuals and graphs to help illustrate in the reader. I hope the reader understand better what I'm referencing when I'm talking about like CFD or things, as well as expand my findings and strengthen the connection to my intended audience. And then I will also go back through and like revise anything as well as fix any mistakes that I think are there. So here's some of the feedback I received from peer reviews. We had some strengths as well as some areas of improvements. For my areas of improvements, I'm going to take it and try and fix as many things as possible, but overall the peer reviews are very helpful. Yeah. Here is my works cited and all the research I used for my project. There might be more coming if I find more. If not, this is it. And thank you for your time, and I appreciate any feedback.